Nik Bear Brown. Build it with a CLI, then take it apart. Fast enough on average is how safety-critical AI fails. The model passes every test. 65 milliseconds mean latency. Deadline is 100 milliseconds. Then a GC pause fires during inference. One run takes 125 milliseconds and the deadline is missed. The deadline you must never miss isn't the mean, it's the worst case. WCET, worst case execution time. A model that passes on mean latency can fail on WCET. Ask for the experiment. In the terminal, Claude, write realtime.py, inputs deadline in milliseconds, deadline class, and an array of measured latencies. Compute WCET from the tail, not the mean. Classify soft, firm, or hard. Emit a verdict plus a recommended pattern if the model sits in a hard safety loop. Read it before trusting it. WCET is the 99th percentile of the latency distribution. Not the mean, not the maximum of a short run, but the tail. A soft deadline accepts occasional misses. A firm deadline treats any miss as a failure. A hard deadline requires the system to prove no miss is possible. WCET must be below the deadline with margin. Run it. The latency histogram builds bar by bar. 15 bins from 30 to 150 milliseconds. Most runs cluster around 65 milliseconds. The bell peak. 3 bins extend past the 100 millisecond deadline. Those bars are crimson. The deadline line appears. WCET, 125 milliseconds. Deadline missed. That is the baseline. Add jitter. GC pauses and DMA stalls push the tail out further. Iterate. Claude. Add jitter from a GC and DMA stall and show the tail blow past the deadline. Rerun with GC jitter. New crimson bars appear at 130 to 180 milliseconds, well past the original tail. The mean is still 65 milliseconds, unchanged. WCET is now 180 milliseconds. The deadline was 100. GC jitter alone doubles the worst case. The average tells you nothing useful here. Real-time isn't fast, it's bounded. The average latency tells you what normally happens. WCET tells you what the system guarantees under load. Optimizing the average while ignoring the tail is the classic safety failure. The GC pause doesn't care that you're running a neural network. Your move. Collect a real latency distribution from your target under full production load. Not a synthetic benchmark, but the actual inference times during normal operation. Run realtime.py on them and check whether WCET fits inside your deadline class. The output beats in this video use illustrative distributions. Swap in your measured array to get the honest verdict. Nik Bear Brown. Build it with a CLI, then take it apart. At Nik Bear Brown, nikbearbrown.com.